Okay, so we are still on solving chemical equation now. Let's taking some examples and look at, let's solve this. You have 0.25 x raised to power x plus 1 is equals to 16. So this is the base. The base is 0.25. And when the base is a decimal, you have to convert the base to fraction. So 0.25 is the same thing as 25 over 100, which is now raised, all is raised to x plus 1 equals to 16. And you have the base 25 over 100 and 16. Now we can simplify any fraction down to the simplest form. So 25 25 in 100 is 4. So that will be 1 over 4 raised to power of x plus 1. So that will give us 16. So now this 1 over 4 can also be expressed as 4 raised to power minus into brackets s plus 1. So we are using brackets because this is an expression. The power is an expression x plus 1, which is going to give us 4 raised to power 2. So this will become 4 minus x minus 1. So it equals to 4 raised to power 2. And when since the base is the same, we eliminate the base, you have minus x minus 1 equals to 2. So if you collect the like terms, you have minus x equals to 2 plus 1. So minus x is equals to 3. So to eliminate the minus, since it's not, you are looking for a plus x, so you take the multiply both of the equation by minus, so you have x equals to minus 3. So if you are getting much value from the video, please click on the subscribe button and share it with your friends so as to get more. See, now we are still going to take the last example on solving indical equation. Now we want to take a particular example. In this example, we have 5 raised to power 2x, 5 raised to power 2x plus minus 26 raised to power multiplied by 5 raised to power x, now plus 25 equals to 0. And when you see an equation like this, you have 3 index or 3 terms. First index is 5 raised to power 2x. Second index is related with the first, because you can see base 5 here, and the last index, the last number here is also a number. So you can relate it with a quadratic expression, because every quadratic expression is of the form ax squared plus bx plus c equals to 0. So we can relate it with quadratic equation. Now, so how do we now transform this equation to something like this? So what we do now is to let the index here, 5 raised to power x equals to y. Can you see now? So in this case, you have, anywhere you have 5 raised to power x in this equation 1, you replace it with y. So you can have this one to be 5. The first time it can be broken down to 5 raised to power s all raised to power 2, which is equal minus 26 5 raised to power x plus 25 equals to 0. Get it now? Now you can now begin to substitute for 5 raised to power x in this equation. So this one will become y raised to power 2 minus 26 y plus 25 equals to 0. So this is a quadratic equation now. In this equation now, if you compare this equation with this one here, you discover that your a here can be any number. A is the coefficient of this term, the first term here. So you can see now the coefficient number that is multiplying the alphabet here is 1, and the number multiplying the y here is minus 26, while the number here is c, 25. So quadratic equation can be solved in 4 ways. You can solve it by factorization, can solve it by the use of quadratic formula. You can solve it with completing the square method, and you can also solve it with the use of graph. So these are the 4 methods we use to solve quadratic equation. So I will try and solve this equation by factorization. So when you are factorizing, you are looking, this is c, 25. I'm now going to look for numbers you can multiply together, which will give you 25, and at the same time, when you add the numbers together, you have minus 26. So 1 times 25 obviously is 25, right? Or 1 plus 25 is plus 26. So how do we do that? Now if you minus 1 times minus 25 also is 25, right? Because minus times minus is plus, and minus 1 plus minus 25 is equals to minus 1. So obviously the factors here is 1 and minus 1 and 25. So this second term here will be broken down into the factors y squared minus y, transform 1 minus 1 to minus y, and that's because the unknown here is y. So the coefficient of this minus y is minus 1, plus minus 25, minus 25y, right, plus 25 is equals to 0. So by the time you are looking at it to confirm, minus y minus 25 will give us minus 26. So you can now factorize this expression. So bringing out the factors here, you have y is when you divide it, you have divide y squared by y, you have y minus 1. So the common factor here is 25. 25 y minus 1 equals to 0. So you can see now that your factors here is y minus 25, then y minus 1 equals to 0. So we are trying to look for y. The first value of y minus 25 is equals to 0. We got y is equals to 25. That's the first value of y. And the second value of y minus 1 equals to 0. You get y is equals to 0 equals to 1. So your values is y can either be equals to 25 or 1. So which one will it be? When you go back to this now, y raised to power 5 is equals to y is equals to 5 raised to power x, 5 raised to power x. So you have either 5 raised to power 1 or 25. So your answer here is your y is 25. So what will you multiply by 20? What will you? So if you bring back this equation, where you have said let 5 raised to power x be equals to y. So your y here is 25. If 5 raised to power x equals to 25 in the first place, so what is x? So you have 5 raised to power x equals to 5 raised to power 2, right? And you cancel it as x is equals to 2. Now, or if 5 raised to power x is equals to 1, then if you have this one, you have 5 raised to power x equals to 5 raised to power 0, because the value of 1 in index is the same thing as raised to power 0. So you cancel it as you have s is equals to 0. So s is equals to 0 or 1. That's the solution to this. So this is the end of the indical equation. We are now going to be moving to logarithm in the part 2 of our lessons of today. So Once again, subscribe and share the video with your friends and loved ones. Thank you.